Our next speaker is Dr. Masoud Vaziri. He's a graduate of electrical engineering from Purdue University and an MBA graduate of University of Texas at Dallas. He's a senior member of Institute of Electrical and Electronics Engineers. And since 2009, he has been an adjunct professor of electrical engineering at University of Texas at Dallas. Dr. Vaziri has been a director at Nortel and a distinguished member of technical staff at Siemens. After 6 years of research and development for a new wearable technology product, Dr. Masoud Vaziri established Eye2Eye in 2012, and that is what he's going to talk about. And his product is called iPal, and it's just an accident in the name. So with that, please give a warm welcome to Dr. Vaziri.
Good evening, and thank you for being here. I appreciate PayPal and the organizers also to provide this opportunity for us to come together and talk about something that I'm passionate about. About 6 years ago, I started working on a project that today we call it iPal. I wanted to capture my interaction with my daughters without having to use any camera. You know, when you use a voice recorder, all you have to do is you push a button, and from there on, everything is going to be recorded. I wanted the same ease to record my eyes. In other words, I wanted to turn my eyes into my own camera. Let's look at personal computers. We started with desktop, and here I'm looking at form factor. We started with desktop, then we went to laptop, which is smaller. So on your desk, on your lap, and then it's a pocket computer. We call it smartphone, but it's really a computer that fits in your pocket. So that's one trend. And after laptop, we have had another trend. We have tablets with multi-touch and touch screen. I believe there is a third branch, which is going to change human life for better in a big way. And that is wearable technology. Let's look at some of the ways that we have been interacting with computers. We started with command line interface, and then we went to graphical user interface. We have been using graphical user interface for a long time. And recently, there has been some hand gestures for games. But really, the one that I find very important is Siri. Siri is one of the things that Apple has introduced, but it has not been appreciated as much as it should have. To me, Siri is a paradigm shift in how we interact with computers. And you can see by the name that it has been given, they call it digital personal assistant. It's a personal assistant. In the past, we used to go, well, even these days, we go to computers and ask a question, do search, and things come to you. With Siri, it's different. You could be driving and you can ask Siri, what's the temperature, where do I turn? And it can give you all the answer, as if it's a real person next to you. That's how I see our relationship and how we interact with computers in future. Of course, other companies realized the innovation that Apple brought to us, and they have followed the suit. And the latest development in that is Cortana from Microsoft, which came after 4 years that Apple has introduced Siri. Now, just look at this and look at real-life personal assistant. Real-life personal assistant, you have seen these people in offices, and you could have been assistant to somebody else. It's not just about talking and understanding what the other person says. We are mobile, and the most important sense that we have for mobility is our eyes. None of these personal assistants have eyes. They have no idea what you see. They are in dark because they are blind. And that's where iPal comes into play. So the first generation could just hear and talk. With what we have been working on, with the fact that we can turn your eyes into your camera, then you can share your eyes with that digital personal assistant, and you can use the power of cloud computing to make sense of what you are seeing. There are already software tools that do object recognition. So really the missing link in this picture was being able to digitize the human eye interface and make it available to these other apps. So really iPal is about giving the sense of sight to digital personal assistant. As a result of that, we will have computers that no longer you need to go to them. They will come with you through your life, and they would anticipate your need, and they would jump in when you need help. I will give you some examples that we can do with iPal. So really, the simplest way that I could explain what iPal does, iPal knows what your eyes see and do. Of course, the audio is there. Everybody else has done it. We don't mention much about audio because the key thing that we bring to the table is the sense of sight. There are lots of cameras, wearable cameras out there. And every one of them, they claim they can record what your eyes see. And I will show you, none of them record what your eyes see. But let's set the background. Let's explain the baseline. Here is the human field of view, the eye's field of view. You have two peripheral views, and where they overlap, it's called binocular field of view, which is about 35 to 40 degrees. Now, we can look at the same field of view. This is in horizontal plane. We can look at it in vertical plane. So, and this is simplification, by the way. So if the whole purple is your peripheral view, the binocular view is less than 10% of it. It turns out the binocular view is what you see, peripheral view is what you detect, and the part that you read is even much less than this. It's like 1 degree or so. If you do this at home, you try to read a book and just put another few characters a few degrees away. Your eyes cannot read it. So anyone that claims that they can record what your eyes see, they should be able to keep their head straight, and as you move your eyes up and down along these plane, they should be able to record exactly what this binocular is. And if you pay attention to somewhere on this, there is a word that you are reading it, they should be able to zoom on that. That's what we mean by being able to record or communicate what your eyes see. It turns out, that should be design, wearable design requirement. It turns out to have such a device, you have to wear something. It has to be a pair of glasses with existing technology. And then there are a bunch of criteria that has to be satisfied for wearable technology. And some of these have been ignored because people are excited about just getting a new technology out. The most important real estate that we have is on our face. It's extremely important what you build looks good. It can be customizable. People don't call you name, don't call you cyborg and stuff like that. It has to give you benefits. If I look here, more than half, they don't wear glasses. Well, it has to give you enough benefits to encourage you to really want to wear these pair of glasses. I will show examples that we offer that you would want to use these pair of glasses. And if it's wearable, you have to judge it with every criteria that you have for other wearables, like shirts, shoes, and everything else. You should be able to use it all day. You cannot change a wearable after an hour or run out of battery. It has to be easy to use. You cannot put a touchpad here and look through a screen and then go through the screen and do these things. People who see you, you scare them. They don't know what you are doing. So you have to be aware of all of that. And most of another criteria is it has to be easy to store. Some of the ones that I have seen, you need to have a kind of laptop bag to carry it in your car. It wouldn't fit into your standard place that you have for eyeglasses case. You have to use the glove box. Some of them, they don't even fold. So this is what we have. This is iPal. It's a pair of glasses, which I have a mock-up here, with a control module. It has two cameras that I will show. They look at the scene. And it has two other cameras that tracks your eye movement. And using some algorithms, we relate everything to each other. These cameras can zoom, they can see. They have access to your peripheral and binocular field of view. And once you have this technology, once you can see what once you have access to what you see, there are a bunch of applications that no other wearable camera dares to talk about. We talk about, for example, well, just camera itself, it's given. We can, if we can see what your eyes see, we can take picture. And we do that. We do that without lifting a finger. We can use eye gestures to take a picture. And we can use eye gesture to record video and broadcast it. So that's just the basic thing. When you look at iPhone, the phone application on iPhone is just one app. There are so many other things on iPhone, and that's what makes it powerful. So on this platform that we talk about, well, we have camera. It has to have camera. But it has these other applications, and there are way more you can do. With driver assistant, if you are drowsy and you are driving, we are detecting your eyes. We see your eye closure. We can, over time, know that it was this wide open, and then it's getting smaller and smaller. We can alert you before something bad happens. For shopping assistant, there are apps that you can put on your phone today, and if you point at a label or product, it can bring up the reviews from Amazon and other things. Well, why do you need to take the phone, get it on, bring up the app, and do that? And these multi-processes discourage us from using the technology. Why don't you just look at it, and this computer, this wearable computer that is with you, anticipates your need, and then brings up the review. And then you can choose to read it or ignore it. Activity tracker. We go and do exercise. There are so many things. Well, this has access to your eyes. Once you are going through the bike, whatever calorie you burn, everything is recorded. Some of us might have these wrist solutions that, like Fitbit and other things, that has an accelerometer, and it measures how much you moved. But if you are biking, if your hands are not moving, it's not going to really detect that, right? Because it detects your body movement. But in this case, if your eyes see it, you can capture it. And telepresence is another application that it's just up to today, when you talk about telepresence, everybody thinks telepresence is video conferencing. Well, video conferencing or webcam is just half of the story. How I look like is half of the story about me. The other half about me is what I'm looking at. And that part has been ignored because it's hard, because nobody has access to your eyes. And we can make that possible. We can allow somebody to watch through your eyes and see exactly what you see. And we can also give them the capability to actually move these cameras as if they are moving your eyes in that direction. I could be looking at this gentleman, and somebody who's watching through my eyes could be looking at somebody else. This is truly telepresence, as if that person is there and that person decides what to look at, not just follow my eyes. So no other camera can do any of these things. Because of these, we say we are really reinventing camera. Here are the scene cameras that we use in another style. And there are two micro cameras that look at your eyes. If I want to summarize my presentation in one slide and everything about iPal, it would be this one. iPal is really digitizing the human eye interface. That's saying it in engineering terminology. In plain English, it knows what your eyes see, and it knows how your eyes react to what you see. So in engineering courses, they may say it's the transfer function of that interface. Anyway, input to our eyes is the scene and everything, and output is your eye movement. You focus on a face, you focus on a shirt, and you turn your eyes away from one to the other one. We detect all of those, and we make sense of them. I would like you to remember this because we are usually asked, well, how does iPal compare to Google Glass? This is Sergey. You guys know him probably better than us. Google Glass has a narrow field of view camera, which is up there. In this picture, and you can read a lot about Google Glass, and they tell you that Google Glass sees what your eyes see. Well, just look at this picture. Google Glass is looking up, and Sergey is looking down. There is no correlation between what Google Glass is recording at the time and what Sergey is looking at. And this story is the same with every other wearable camera. Whereas when we use handheld devices, with handheld devices, you choose exactly what you want to look at. With head tracking camera, it is your head direction. If we were all statues, these solutions would be good because statues' eyes do not move. If you set the camera one way, you can always get it. So these kind of camera are actually like clocks that they don't work. They are guaranteed to be right twice a day. And these things are like 8% or 10% are right. If you don't purposely try to align them properly. But the whole purpose of making things hands-free is not to point things with your neck. It's actually harder than your hand because that's not the natural thing for me to point a camera with. The natural thing is to use your eyes and look at various things that you are interested in. So how does Google Glass compare to iPal? Well, it doesn't capture the input, and it doesn't capture the output. So from imaging perspective, these are like apples and oranges. We are providing a new user interface by digitizing that human eye interface. And because of that, that's a new platform. You can use it for medical application, for security, for any application that you want. And that's really what makes this a platform. And that's why it has kept me 6 years working on this. There are a bunch of technology that we have developed as we work on this problem. One of them is eye tracking. Eye tracking today, eye tracking is not a new technology. It has been around for 35, 40 years. But you need a wall plug to run some of those algorithms, or you need a big battery, or it may run for a few minutes and it's over. And then there is gaze tracking, eye gesture coding and encoding, and the whole system putting these things together. So what we mean by eye tracking is really detecting your pupil. We take 60 pictures per second of each eye, and we locate your pupil, and we look at the two eyes. If you look at eye trackers out there, up to recently, they were just tracking one eye. From get-go, we said it has to be two eyes, because with two eyes, you get way more information. You get the depth information, and you get many more. So we locate the pupil and figure out how the eyes are aligned. And then gaze tracking is simply relating the eye tracking to what's happening in the scene. If I'm looking straight, you wouldn't know I'm looking at the gentleman back there or there is nobody back there. It's the gaze tracking that correlates my eyes to what is in the scene. In this case, for example, he is looking at the key that he's getting from that gentleman at the hotel. I mentioned we use this wearable computer with eye gestures. And these are some of the eye gestures, but there is way more. With iPal, you can define your own eye gesture, and you can use that user-defined gesture to control things. I mentioned wearable must look good, and these are some pictures that we have taken from different people. So once you make it easy for people to basically mass-produce pictures and images, it should be also easy for them to share it. And here are some options that we will provide. You can, on camera option, you can take a picture every time you wink or double blink. You can take pictures randomly. You can wear the camera, and all day it takes pictures, and you have no idea when it took a picture. In the evening, you will be surprised. You have a reason to look at it because you don't know what pictures were taken. It can take a picture at fixed time interval. You can say, take a picture every 2 seconds or 10 minutes. You can also set this to share on your favorite social network. So this really automates user-generated content. One of the difficulty with recording video is pointing this camera all the time. You can't enjoy the moment and record it. There is this contradiction. You either have to go for this or the other one. But when your eyes are your camera, there is no contradiction. You can have your cake and eat it too. These are some pictures. We say it sees like your eyes, so it has the wide-angle view and narrow-angle view. You can take a picture with your eyes. You can take your smartphone and take a picture, or you can just have your wearable computer and do that. This is another thing that none of these wearable cameras can claim. We can actually crop a scene with eye gestures. If you take any camera in the world today, it doesn't matter from where or who made it, none of them can pick one audience here, hands-free, and just take, let's say, a headshot from anybody in this group. We can do that. With eye gesture, we can say, hey, I want only this piece. You can go around it, and the camera detects it and takes that picture. There are apps, of course, you can put it on your smartphone and do the same thing. If you want to do it once, it's OK. But if you want to do it over and over, it adds up. And besides, this allows you to really save the editing time. You can take a picture of what is important to you and share it. Many times, by the time you get the camera, your smartphone ready, really the moment is finished. You don't have time. If your eyes are your camera, you can capture all these unexpected moments. And that was the case with myself when I was trying to record my interaction with my kids. They always do all these creative, unexpected things, and you can never capture them. You can capture them if your eyes are your camera. I mentioned if your eyes are your camera, you can record it, you can broadcast it, and that's another feature. I also talked about the telepresence. With telepresence, we can really make the world a global village. You can be anywhere, anytime, and your eyes can see what you want to see. And in this case, we have Dad, thousands of miles away. He is looking through his wife's eyes. She is wearing an iPad. And instead of looking at exactly what she's looking at, he can control the camera there and look at whatever he wants. And that brings me to the end of the presentation. I'm sure you have many questions. I didn't cover everything. We have information on meetipal.com, and we'll be glad to answer any question you have. If you would like to send your questions to info@meetipal.com.